लगता है इस बात को आप लोगों के बीच में संदेश देते हुए। आप लोगों को बहुत बहुत धन्यवाद।
Dear learners, Namaskar and welcome you all in today's session. The topic of today's session is insertion and selection sort. In fact, we will discuss the methods, examples and complexity analysis about these two sorting algorithms. In previous we discussed the bubble sort, so we will see how these methods work. And so let us start with the insertion sort algorithm. So it is one of the popular algorithm. So in the insertion sort, basically it is applied on a smaller size of data sets. In the insertion sort, at the name insert is there. So what does mean by insert? Insert means we divide the given list of data into two parts. One is sorted list and another is unsorted list. So initially the sorted list is empty and unsorted list contains all the data which are required to be sorted either in increasing or in decreasing. Unsorted list and assume that it is already sorted. Then what we do, we consider the second element from the list, that is unsorted list, and we place it into the sorted list by comparing it from the last element of the sorted list. So in the beginning there is only single list in the sorted, so we compare the second item of the unsorted list with the single item which is available in the sorted list, and we place the second item accordingly into the sorted list. Then we take the third item from the unsorted list and we compare it with the last item of the sorted list, that is the second item, and we see if the third item is smaller than the second item of the sorted list, then we again, if the first item of sorted list is smaller than the third item of the unsorted list, then we shift these two items one place toward the right side and make the place for the third item to be inserted. So now by doing this, first three items are now sorted, and next we consider the fourth item from the unsorted list and we again compare it with the last item of the sorted list, that is third item, and if it is the fourth item is smaller, then we compare with the second item of the sorted list. If it is not smaller, then there is no need to further compare with the second item. Or if the first this fourth item is larger than the third item of the sorted list, then we insert the new item, the fourth item from the unsorted list at the last place of the sorted list. So this is that last we will get the list into the sorted order. Now I would like to discuss the algorithm or a function which we can write to implement the insertion sort algorithm. So here we can see that in this we have a function named insertion sort, and we are passing two parameters, the array, the list which we want to sort, and number of items which are available into the list, that is int n. N is the number of items to be sorted. Then we declare variables which we required during the insertion sort algorithm, like we use two loops. So for that we have declared two variables I and j, and we have used a temporary variable key. Key basically we consider in the beginning it will store the first item, and in the next iteration when we go it will contain second item, and so on. That is whatever value of outer loop is there. So outer loop is I is equal to 1 to less than n, and whatever the value of I is. So initially if I is 1, then the key will contain the second element of the unsorted list, and then we use another loop, inner loop, that is mentioned here with the while loop. So while loop initialization is being done from j is equal to I minus 1. So if I is 1, then it will be initialized as 0, j is equal to 0. So then we compare the condition between the while loop, that is j is greater than equal to 0 till the j value is greater than equal to 0, and aj is greater than key, the key which is required to be inserted into the sorted list. So when these two conditions are true, we continue this inner loop, and what we do, we shift the item, we continue this one and shift the item one place toward the right from the sorted list till the condition is true. So as soon as this inner loop becomes false, then we store the element at the jth position. So it is aj plus 1 will be stored that key value. So that is how the inner loop will complete, and then I will be incremented by 1. Now I will be 2. So the key will now contain the third item from the unsorted list, and j will start from I minus 1, that is 1. So j will execute for j will execute for 1 and 0, and also it will compare the first item as well as second item from the sorted list from the value which is stored into the key. And if the value stored in the key is smaller than the items which are there into the sorted list, then one by one till the items are there in the sorted list, they are shifted one place toward right, and a location is found from the sorted list where that particular key is inserted. So this process will continue till the last element, and at last we will get the entire list sorted in ascending order. Similarly, if we want to do the sorting in descending order, then there will be certain changes in the conditions or in the program. So that is how the insertion sort algorithm works. Now I would like to discuss one example how exactly this algorithm works. Let we have been given in the left top, we have the list of elements which are required to be sorted. So in this one we see that the 50 is the first element. So we take the first element and we assume it is sorted. So the right side top array shows that 50 is already sorted. Then in the next pass 1, we take one more element, that is fourth element number value 4. So we compare 4 with 50. Now we see that 4 is smaller, so 50 will be shifted one place right using the t. So after doing this, we will get we will see that the first two items are sorted. 40 is the smallest at the first place and 50, the larger one, is at second place. So first two items are now sorted and remaining items are still unsorted. Then in next step, next pass, next iteration, we consider the third element from the unsorted list, and that is 55. Now we compare the 55 with the first item of the sorted list from right side. So first item from right side is 50. 50 is smaller than 55, so there will be no swapping, and now these three elements for 50 and 55 are sorted. Now in the next pass we consider one more element, next element, that is fourth element, and here we see that fourth element is 25. So we compare 25 with the last element that of the sorted list, that is 55, because 25 is smaller than 55, so we continue comparing with the previous element than 55, and previous element of 55 is 50. So 25, again compare 25 with the fourth. Here 4 is smaller than 25, so there is no need to do the comparison further, and these two elements which are bigger than 25, that is 55 and 50, they are shifted one place toward the right, and 25 to 4 element are now sorted. Similarly, in the next pass we take the next element from the unsorted list, and that is 10. So again we compare 10 first with 55, it is smaller, so we continue the comparison with the previous element, that is 50. Again the 10 is smaller than 50, so again we compare 10 with 25, it is smaller than 25, so we continue this comparison with 4. Here the 4 is smaller than 10, so we stop this comparison, and the three bigger element which are bigger than 10, they are shifted one place toward the right, and the 10 is inserted at the second place, and by doing so the first 5 elements are now sorted. Similarly, in the next pass we take the next element, that is 40. So now we compare 40 with 55, that is the last element from the sorted list, and we see that 40 is smaller than 55. Then again we compare it with 50, and again it is smaller than 50. So we can compare 40 again with 25, and here 25 is smaller than 40. So no further comparison is required. So the bigger element which are toward the right, and so a place is made to insert the element number 40. So doing this, we get that all the 6 element 4, 10, 25, 40, 50 and 55 are now sorted. Similarly, we consider the next element from the unsorted list, that is 36, and we do this process again, repeat this process, and thus 36 is placed at its appropriate place. So at last we consider the last element, that is 5, and we compare it starting from the rightmost element of the sorted list and continue till we get the smaller element in the sorted list. We stop the comparison at that particular point. So here in this one we can say that 5 is till 10, it is smaller, and as soon as it is compared with 4, it is greater. So the all elements from second position till the second last position where 55 is stored, they are shifted one place toward the right, and second position is made free for inserting the element number 5. So after doing this, we see that all the elements are now exhausted, and thus we got the sorted list. So that is how insertion sort algorithm works. Hope it is clear to all of you. Now I come to the point, what is the complexity? Complexity in terms of time and complexity in terms of space. So if we go to the algorithm, we see that in the insertion sort algorithm, there are two loops. One is the outer loop and another is inner loop. So outer loop is executed how many times? Starting from 1 till less than n. If we have n number of elements, so it is going to be executed n minus 1 times. And for each value of outer loop, the inner loop is also going to be executed. Initially it will be executed 1 time, next minus 1 time it will also be executed. So based on these two loops, we can analyze what will be the time complexity of the insertion sort. So there are three types of, as we know, three types of time complexity. One is best case, average case is another type of time complexity, and worst case is the third type of time complexity. So in case of insertion sort, best case will be when the list is already sorted in the desired order. So in that case, what will happen if the list is already sorted? So this inner loop will execute only once for each value of outer loop. So outer loop will be executed n minus 1 time. So for each value of outer loop, it will be executed only once, because it will, by executing only once, it will get to know that the remaining items are smaller and there is no. So that is why we can say that the time complexity of this insertion sort will be order of n. That will be the best case time complexity, and average case will be order of n square when this inner loop is also executed many times for each value of the outer loop. And the worst case will be exactly order of n square when the list is already sorted but in reverse order. That is, we want to arrange the element into ascending order and the list is already sorted in descending order. In that case, both of the loop, inner loop and outer loop, will be required to execute maximum number of times. So that is about the time complexity. Now I come to the space complexity. So here, by looking this algorithm, what extra variables we are using? In fact, we are using only a single extra variable, which is key, that is used as temporary. So the extra space required is only for the 1. So this is about the time and space complexity of insertion sort. So hope it is clear to all of you. Now I come to the next sorting algorithm, that is known as selection sort. Here in this one, selection sort, we basically in every iteration or every pass, we try to find the smallest element from the unsorted list and we place it at its appropriate place. So in the beginning, when we have unsorted list, we start the element, and wherever we find the smallest element, we place that at the first place, and the first place element is transferred to that smallest element location. So now the smallest element will be at the first place. Now we consider the second element and we compare it all the unsorted element and we try to find the second smallest element from that. So once we find the second smallest element, then we swap the second position element from that second smallest element. So this process is continued till last, and at last we will find the entire list into the ascending order, that is in smaller to larger size. Similarly, if we want to arrange it in descending order, then the logic will be changed. So we will try to find the maximum or largest element at first time and the second largest at the second time, and will place it at appropriate place. That is how the selection sort algorithm works. Now here is the function for selection sort. So we can see that we are again passing two parameters, the list of elements which is to be sorted, that is array, and number of items which are present into the array. These are the two parameters which are going to be passed to the cell sort algorithm. Again, we define few of the temporary variables which will be used in the sorting process. So we have taken 4 temporary variable I and j for 2 loops. Here again there will be 2 loops. Outer loop, for that we have used I, and for inner loop we have used j. Similarly, we have used a temporary variable for performing the swapping operation, and min position is a variable which is used to store the position or index of the minimum smallest element's position or index. So that is the purpose of these variables, and we can see that the outer loop starts from I is equal to 0 till I is less than n minus 1. So if we have say n number of elements, so how many times it will be executed? It will be executed till n minus 2, till n minus 2, that is n minus 1 time. If we have 10 elements, so outer loop will execute 9 times. Okay, and for every value of I, say I is 0, then in beginning this min position variable will store the value of I. So when I is 0, min position will store 0th value, and then we execute another inner loop, that is j is equal to I plus 1. So I is 0, so j will start from I plus 1, that is 1, and it will continue till less than n, that is n minus 1, till n minus 1. So for every I, j will execute from I plus 1 till n minus 1, and we compare whether the min position, what is the position of the smallest element by this if condition. So if array j is less than array min underscore pos, so the min position will contain the index of the smaller values element. So by doing this, our position of the smallest element from the unsorted list, and then we swap it with the I outer loops element, that is when I is 0, so we swap it with the first element, and if I is 1, then we swap it with the second element. So we can see that this execute from I plus 1 till less than n, that is n minus 2 times, and for every value of I, in worst case it will execute n minus 2 times. Okay, so this will be used while doing that complexity analysis. We will discuss later on. Now I want to discuss one example to make it more clear. We have this 50 is the first element, then we try to find the smallest element from the remaining elements. So we get to know that this 4 is the smallest element. Then we swap this 4 with the 5. So now 4 is placed at appropriate place. Now we consider the second element. So second element is now 50. We again try to find the next smallest element. So now next smallest element from the unsorted list is 5 arranged. Now we compare the third element, that is 55, with the next smallest element. So now the next smallest element among the unsorted list is 10. So 10 will be swapped with 55. So that is how this process will be repeated. Now I come to the time complexity analysis of the selection sort algorithm. So we can see that the time complexity of selection in this one. So already we have seen that the outer loop is also executing n times. So n into n, that is how it is order of n square. Our time complexity, so there is no extra variables except the temporary variables. We are not using any other variables, so there is no much time complexity involved apart from one extra memory required. So that is about the complexity analysis of selection sort. So dear learners, today we have discussed 2 algorithms, one insertion sort algorithm and another selection sort algorithm. We also discussed example about it as well as your time and space complexity analysis. Thank you.